A sheet of foil, a spoon of salt, $1 of iron powder, 12 hours of heat, $0 on your bill, and the gas industry has known this longer than you have been alive. This is not a hack. This is not a life tip from someone who read something online. This is chemistry, documented, tested, published, and quietly commercialized for over 100 years, in a form you were never supposed to scale up. The reaction is called iron oxidation. You already know it by its common name, rust. When iron is exposed to oxygen in the presence of moisture, it oxidizes. It forms iron oxide. And the process is exothermic, meaning it releases energy, not light, not sound. Heat, raw, sustained, measurable heat. The chemical equation is simple. 4 atoms of iron react with 3 molecules of oxygen to form 2 units of iron 3 oxide. The enthalpy of that reaction, the total heat released, is negative 1,748 kilojoules per mole. That is not a trivial amount of energy. For perspective, 11 grams of iron powder, roughly 2 teaspoons, releases 81 kilojoules of heat. Enough to feel. Enough to warm your hands for hours. Now here is where it becomes interesting. This reaction, on its own, is slow. Iron will rust over days, weeks, months. But if you add a catalyst, something that accelerates the process without being consumed, the reaction speeds up dramatically. And the most effective catalyst for iron oxidation is something you have in your kitchen right now. Salt, sodium chloride, table salt, the same ingredient you put on your food tonight. Salt does not participate in the reaction. It accelerates it. It breaks down the protective layer on the iron surface, allowing oxygen to reach the metal faster. Add water, even trace moisture from the air, and the reaction rate increases further. The iron heats up, the heat sustains. If you control the variables correctly, you can maintain temperatures between 50 and 34, that is 130 to 165 degrees, for 8 to 12 hours continuously, from iron, salt, and air. Now, you might be thinking, this sounds familiar, and you're right, because you have already bought this reaction hundreds of times. You just did not know it. Every disposable hand warmer sold on this planet, Hot Hands, Grabber, Little Hotties, every single brand uses this exact chemistry. The ingredients listed on the packet are iron powder, water, salt, activated charcoal, and vermiculite. That is it. 5 ingredients. The iron provides the fuel. The salt catalyzes the reaction. The water provides the medium. The activated charcoal distributes the heat evenly and helps conduct it across the surface. The vermiculite, a mineral that absorbs and slowly releases moisture, acts as a regulator, preventing the reaction from burning too hot or dying too fast. You tear open the plastic wrapper. Air hits the iron. The salt accelerates the oxidation. The pack reaches operating temperature within 20 minutes, then sustains it for 6 to 12 hours depending on size. The global hand warmer market is valued at approximately $1.8 billion. Hot Hands alone generates an estimated $250 million in annual revenue. The raw materials inside each packet cost fractions of a cent. The iron powder is worth less than a penny. The salt is effectively free. The charcoal and vermiculite add negligible cost. The retail price is $1 to $3 per pair. You're not paying for chemistry. You're paying for packaging. You're paying for a brand name printed on a pouch that contains a reaction your great-grandmother could have assembled from a hardware store in a kitchen cupboard. But here is what they do not want you to do. They do not want you to scale it up. A hand warmer is designed to heat your palm. It contains roughly 11 to 40 grams of iron powder in a pouch the size of a playing card. But the reaction does not care about the size of the pouch. The chemistry is the same at 11 grams as it is at 100 grams. When you scale the mixture, more iron, more salt, more charcoal, more vermiculite, you scale the heat output proportionally. Take a container, a metal tin, a ceramic bowl, even a thick cardboard box. Fill it with a mixture of iron powder, table salt, activated charcoal, and vermiculite. The ratios used in commercial warmers are approximately, by weight, 16 parts iron, 1 part salt, 1 part charcoal, 1 part vermiculite, with enough water to dampen, not soak, the mixture. Stir it, expose it to air. The reaction begins. Now wrap the container, or place it inside, a shell lined with aluminium foil, shiny side facing inward. This is the second half of the system, and the half that almost nobody explains. Aluminium foil reflects up to 95% of infrared radiation. Infrared radiation is the primary way heat travels through air at short range. When the iron-salt mixture generates heat, that heat radiates outward in all directions. Without the foil, most of it dissipates into the walls, the floor, the open air. With the foil, 95 out of every 100 units of radiant energy bounce back inward, toward you, toward your shelter, toward whatever enclosed space you have placed it in. You have just built an insulated exothermic heat cell. It produces no flame, no combustion, no carbon monoxide, no smoke, no open fire risk. It generates heat through a controlled chemical reaction, moderated by charcoal and vermiculite, catalyzed by salt, and retained by a reflective aluminium barrier. Total cost for a pack large enough to heat a small enclosed space for 8 to 12 hours. Under $2 if you buy the iron powder in bulk. The salt costs cents. The charcoal costs cents. The foil costs cents. The air is free. And this is not new science. This is not some garage invention from 2024. This reaction has been understood and exploited for over a century. In 1891, a man named Jonathan T. Ellis of New Jersey filed U.S. patent number 444395. It was a hand and foot warmer based on the exothermic properties of iron oxidation. The patent is public record. It is still searchable. There is no evidence the device was ever mass-produced, but the principle was documented, patented, and entered the scientific record in the 19th century. And the idea that you could scale this reaction, that you could use the same chemistry to heat a room, a shelter, a tent, a greenhouse, an emergency space, was never promoted, never taught, never discussed. And now you need to understand why. The average American household spends approximately $860 per year on natural gas. Multiply that by roughly 60 million gas-heated homes in the United States, and you are looking at a residential natural gas heating market worth tens of billions of dollars annually. That money flows through infrastructure. Pipelines, meters, billing systems, maintenance crews, regulatory agencies, utility companies, and shareholders. Every dollar you spend on gas passes through a system designed to extract value at every node. The pipeline company profits, the distributor profits, the utility profits, the meter manufacturer profits, the furnace installer profits, the maintenance technician profits. And every month, like clockwork, a bill arrives. Now consider the iron-salt reaction. Iron powder can be purchased in bulk for approximately $1 to $2 per pound. 1 pound of iron powder combined with salt, charcoal, vermiculite, and wrapped in aluminium foil can produce a significant heat output for 8 to 12 hours. The salt comes from your pantry. The charcoal is available at any hardware store for pennies per gram. The foil is in your kitchen drawer. The air is free. There is no pipeline, there is no meter, there is no monthly bill, there is no technician, there is no permit, there is no subscription, there is no infrastructure, there is no recurring revenue. And that is the problem, not for you, for them. A $2 heat source that requires no grid connection, no monthly payment, and no professional installation is not a product that can sustain a utility company. It is not a product that generates shareholder returns. It is not a product that justifies a $60 billion infrastructure network. It is a product that makes that infrastructure irrelevant. Let us talk about the foil for a moment, because the foil is doing more than you think. Most people understand aluminium foil as a food wrapping material, something you put over leftovers, something you line a baking sheet with. But aluminium has a physical property that makes it one of the most effective thermal management materials on Earth. It has extremely low emissivity, meaning it does not radiate heat away from itself, and it has extremely high reflectivity, meaning it bounces radiant energy back toward its source. Polished aluminium reflects up to 97% of infrared radiation. Even standard kitchen foil reflects approximately 95%. That means if you create a heat source, any heat source, and surround it with aluminium foil, shiny side facing the heat, 95 out of every 100 units of radiant energy bounce back inward instead of escaping through walls, floors, or open air. This is not a theory. This is measured. Oak Ridge National Laboratory published research confirming that aluminium foil radiant barriers reduce heat transfer by up to 95% in controlled settings. Building contractors already use this principle. They install foil behind radiators on exterior walls to reflect heat back into the room instead of losing it through the wall. That one trick alone reduces heating loss by 5 to 10%. Now, apply that principle to the iron-salt reaction. You are generating heat through exothermic oxidation. You are reflecting that heat inward with a 95% efficient radiant barrier. You are moderating the reaction with charcoal and vermiculite to ensure slow, sustained output, and you are doing all of this for under $2 in raw materials. That is not a hack. That is a heating system. It just does not have a brand name or a monthly payment. Now, to be clear about what this is and what it is not. This is not a replacement for a central heating system in a 4-bedroom house in Minnesota in January. A scaled iron-salt heat cell does not produce enough thermal output to heat a large home to 70 degrees in sub-zero conditions for days on end. Anyone claiming otherwise is exaggerating. But that is not where this technology belongs. It belongs in emergencies. It belongs in off-grid shelters. It belongs in tents during winter camping. It belongs in greenhouses protecting plants from frost. It belongs in workshops and garages. It belongs in the hands of someone whose power went out during an ice storm and who needs 12 hours of warmth to survive the night. It belongs in disaster relief kits. It belongs in the global south, where 3 billion people still burn wood, dung, or kerosene for heat. producing indoor air pollution that kills nearly 4 million people every year, according to the World Health Organization. For 4 million deaths a year, there's a flameless, smokeless, $2 chemical reaction that produces 12 hours of clean heat. And it is not in a single disaster relief manual distributed by any major government agency. The U.S. military has known about exothermic iron oxidation for decades. MRE heaters, the flameless ration heaters packed in every combat meal, use a related exothermic chemistry. They know, they use it. They just never told civilians to scale it. You can walk into any Walmart, any Target, any outdoor supply store and buy a packet of hot hands for $1 or $50. Inside that packet is iron powder, salt, charcoal, vermiculite, and water. You open it, it heats up. It keeps your hands warm for 10 hours. You throw it away, and you buy another one tomorrow. Nobody questions it. Nobody calls it a scam. Nobody says it does not work. The chemistry is so reliable, so well understood, and so universally accepted that a billion-dollar industry has been built on selling it to you in the smallest possible quantity, in a disposable format, at the highest possible markup. But the moment someone suggests scaling that exact same chemistry to heat a room instead of a hand, the conversation shifts. Suddenly, it is too dangerous. Suddenly, it is not practical. Suddenly, it needs regulation. Suddenly, you should just pay your gas bill like everyone else. The chemistry does not change between 11 grams and 100 grams. The reaction does not become less valid because the container is bigger. The science is the science. The only thing that changes is who profits. At 11 grams, hot hands profits. At 100 grams, nobody profits. And that is why you know about one and not the other. So let us do the numbers. 1 pound of iron powder, approximately 450 grams, costs between $1 and $2 in bulk. 1 tablespoon of table salt, 15 grams, costs effectively 0. 1 tablespoon of activated charcoal, available at any pet store or pharmacy, costs approximately 10 to 20 cents. A cup of vermiculite, available at any garden center, costs approximately 15 cents. A 3-foot sheet of aluminium foil from a standard kitchen rolling out costs approximately 5 cents. Total raw material cost for a heat pack roughly 10 to 20 times the size of a commercial hand warmer, approximately $1.50 to $2. Heat output, sustained temperatures of 130 degree hours for 8 to 12 hours. Now compare that to one night of gas heating. The average U.S. gas-heated household pays roughly $867 per year. That is approximately $72 per month, approximately $2.40 per day. For one day of gas heating, you pay more than the total cost of a scaled iron salt heat cell that produces 12 hours of sustained warmth. You are already spending the same amount. The difference is, one method sends money to a utility company every single month. The other sends money to nobody. In 1891, a man patented a device that turned iron and air into heat. In 1923, a Japanese inventor commercialized it. By the 1950s, factories were producing 10,000 units a day. Today, you can buy the same reaction in a disposable pouch for $1.50 at any store in America. The chemistry is proven. The ingredients are in your kitchen. The foil is in your drawer. The reaction produces 0 flame, 0 smoke, 0 emissions, and 0 monthly bills. No corporation patented this reaction because you cannot patent a law of nature. No corporation monopolized the ingredients because they are the most common materials on Earth. And no corporation promoted it as a heating solution because the moment you build one, you stop paying them. Iron, salt, charcoal, foil, air. 135 years of documented science. $1.8 billion in hand warmer sales built on this exact reaction. And not one person in the energy industry ever suggested you could scale it up. Now you know you can. The question is not whether it works. It has worked since 1891. The question is, who told you it did not?